welcome back to learning about statics. We're going to move on now from talking about calculating simply supported beam reactions, and now we're going to apply that into calculating truss forces. To start off, this truss force calculation, it ends up being exactly like a simply supported beam calculation. It's pretty straightforward, but then what we do is we can find out that there are beams connecting each of these points, and at each point, using what's called the method of joints, we can calculate the reaction forces inside of this truss. And when we do that, then we determine whether or not these forces are acting in compression or if they're acting in tension. So let's jump in and we will calculate the reaction forces inside and outside of this truss. So what I've done is I have a truss set up right here. It's a pinned connection at point A, a roller connection at point C, and a 500-pound load is pulling down at point D. So I've drawn a free body diagram to the right of that, and all I've done is replaced my reactions, or my pinned and roller connections, with their corresponding reaction forces. So my truss still exists, and I have FAX and FAY replacing my pinned connection at A, and I have FBY replacing my roller connection, and that should be FCY, excuse me, my roller connection at point C. So FCY is at C. All right, so before we can move into anything else, we continue this problem as if it were a simply supported beam. So my first equation is my equation of equilibrium for the forces in x. So the sum of the forces in the x direction are equal to 0. The only x force acting on the outside of this truss would be FAX that I replaced for the reaction force for the pinned connection, and so that means that FAX must be equal to 0 because there are no other forces. So that's pretty easy right off the bat. When we are done, we'll have several answers. We'll have the 3 reaction forces answers, and then we'll also have force AB, force AD, force CD, and force BC. So we'll have 1, 2, 3, 4, 5 additional answers. So we'll have 8 total answers for this. All right, jumping back. So I figured out that my FAX is equal to 0. Some of my forces in Y are also equal to 0. My Y forces in this case are FAY, negative 500, and FCY. So I'll just write all my positives first because that's how I like to do it. FAY, excuse me, plus FCY minus 500. As we know from our previous examples, we cannot solve this because we have 2 unknowns and only 1 equation, so we need to use moments. Excuse me. So the sum of my moments, again, are going to be at the pinned connection, so about point A. Those are equal to 0. So I will have my moments at A. I'll have, if counterclockwise is positive, 500 is acting around A in a negative direction, a clockwise direction. So I'll say negative 500 times 3 feet plus FCY times 3 plus 7. The total distance there would be 10 feet. So if I was solving, I would say FCY is equal to 1,500 divided by 10. FCY is going to be equal to 150 pounds. And finally, I can take and plug that back in up here, and I get FAY plus 150 pounds minus 500 pounds is equal to 0. And so if I solve for that by combining these two and moving them over there, I would end up with FAY being equal to, should be 350 pounds. So I got FAY equal to 350 pounds. Boom, boom, boom. I've got my 3 external reaction forces that I've calculated. I'm going to end this video here as part 1 because the next part is going to get a little long, and so we'll jump in. Part 1, here are our external reaction forces. Part 2 will be all of my internal reaction forces. So stay tuned for part 2.